Hello, my name's Marty Edwards, and today I'll be presenting on ditching run to failure as part of a winning ICS strategy. A little bit about myself. I'm currently the Vice President of Operational Technology Security at Tenable. My Twitter handle is ICS Marty, so if you want to follow me on Twitter, you can do that. Um, from a background perspective, I started as a control systems engineer. So I have designed, built, maintained these industrial control system and operational technology environments over the past, I'm embarrassed to say, 30 to 35 years. And got recruited into the US government in, about 20 years ago. Worked for the Department of Energy at the Idaho National Laboratory as a program manager there, running some of their industrial security programs. And then, probably the most notable piece of my career prior to joining Tenable is I was the longest serving director of what was called the ICS CERT, the Industrial Control Systems Cyber Emergency Response Team at the US Department of Homeland Security. So kind of a little bit of a unique perspective. I've worked for the vendor, I've worked for the asset owner, I've worked for the government, I've worked for a contractor, and now I'm working for Tenable, which of course is a security provider in this space. So I've got some thoughts on things that we should be looking at, especially in the operational technology world, as far as how do we build a security program in these environments, and how do we talk to these operational technology people, in a language that they understand? Because quite often there's a disconnect between how the information technology people talk about cybersecurity and how the boots on the ground engineers talk about security. These are the men and women that run the power grid or run the water treatment facility, or manage the factory that makes the goods and services that we depend on. And they really speak two different languages. So I'm going to try a new approach with this, and we'll see how it goes. I'm going to do my best to answer questions through the chat function as we go along here. So I really encourage you to take advantage of the chat function and type all those questions in, and we'll see if we can get a good dialogue going here. And I'm hoping this will be a lot of fun. So if you look at operational technology or industrial control systems, a lot of people don't actually know what that means. So these are the computers, the systems that operate all of our critical infrastructure. So if you look at something like a power grid, there's these little black box computers that they tell the breakers and the switches on the power grid what to do, or they tell the pumps in the water treatment facility what to do and how to turn them on and off. There's really complicated control rooms with many, many screens that operators sit in front of and control these environments, and they're all reliant on computers. It's very specialized computers. Now, in some of these factories, we spend tens of millions of dollars in capital expenditures on these systems. So you have $10 million worth of very specialized computer equipment that you're using to run these factories with. And I maintain, and it's a pun intended, I maintain that we're not maintaining these environments properly. We do the capital expenditure and it has a depreciation schedule, et cetera, but we're not really thinking about what kind of cyber maintenance do these systems need? What do we need to do to these systems day in and day out to make sure they stay running? And I'm going to talk about that specifically from a cybersecurity perspective for maintenance. So this is not a new technology, right? This is not a new field of study. People have been studying maintenance and reliability and how to best invest your meager maintenance resources for a long time, right? They've also been assigning risk to these systems. So you have some systems that are highly critical, right? That you have very significant consequences if there's a breach of the system or if the system fails. You've got other systems perhaps that have lesser consequences if there's a failure. And so it's not a broad brush approach, or there's not one solution that fits all. You really need to tailor your security controls for the risk that particular environment, that particular system has, right? In any case, if you lose one of these systems, if one of these highly specialized computer systems stops operating, really significant things happen, right? I mean, you do have consequences where, your factory stops making product, or the power grid goes down, or there's some sort of consequences based on that, right? So, we need to plan through these systems and environments and make sure we're doing the sort of the right size of solution. So let's look at this from a maintenance perspective, or from the perspective of these different styles of maintenance. And if you look at the chart that I've got there, in the old days, in a plant, we basically did maintenance in a reactive fashion. So let's look at this as if it's your automobile, right? So you drive your car and you just keep driving it, and you don't change the oil, and you don't look at the pressure in the tires. You just drive it, and you drive it till it breaks, right? You drive it till you get a flat tire. You drive it until the check engine light comes on, or you drive it until something happens and you have to go get it repaired. That's reactive maintenance, or this run to failure concept. And most maintenance people, and I fully disclose I'm not a maintenance engineer, most maintenance people will tell you that's very inefficient, right? It costs you a lot of money to make those repairs. You typically damage the system worse off than if you would have put some thought into it. The next type of maintenance is to go to a schedule-driven maintenance, right? So you take your car every 3,000 miles, or every 3 months, you take it to the local oil change place. No matter what, you take it in, they change the oil, and you are making sure that you've got a well-maintained vehicle because of that. Well, is it necessary to do that? Is your oil really worn out after 3,000 miles? How do you know, right? Well, the more modern maintenance type of schedules, especially with regards to lubrication and that, is that they will test the oil. So you take a sample of the oil that's in this big machine. You might have $1 million piece of machinery in your factory. They sample the oil and they go, oh yeah, this oil's still in good shape, we can keep running. Or they go, oh, this oil's starting to show signs of breaking down. So what we should do is we should schedule the next time we have some downtime to change the oil in this machine. So we don't have to shut the whole factory down. We have another reason the factory is going to be down to change products or do something else. We'll change oil at the same time, so we minimize the impact to the organization. So this is my premise, is that organizations in the physical world are moving more towards this sort of planned, proactive, predictive maintenance, and it's a much more cost-effective method. So, if you look at the run to failure sort of methodology, I maintain that that's expensive, right? I mean, things happen in an unscheduled way, so it's unpredictable. You don't know when something's going to fail. I think it's actually really, really stressful on the people, right? So if you look at this from a human factors perspective, your personnel, they don't know when it's going to fail. So when it does, it's kind of like all hands on deck. It's stressful, it's costly. The other thing is that this type of failure, this type of method isn't good at a sophisticated adversary or common mode type failures, right? So it's not good if you have some sort of electrical disturbance that burns out all your motors at the same time. Well, you don't have enough spare parts to fix it, right? So very spendy, costly, not very effective at all. So let's look at cybersecurity sort of examples of this, right? I maintain that if you sort of do nothing proactively in the cybersecurity area, and you wait until you have some sort of incident, and in this case, I'm articulating a ransomware incident. That's the same as run to failure, right? You're ignoring your cybersecurity until you have some sort of incident, and then you're paying through the nose to an incident response company, to come back in and try to fix things. Back when I was with Homeland Security and the ICS CERT, my team was the team that would fly away to go and investigate these types of things. And we heard from everybody that, and the numbers may differ, but I think it's at least an order of magnitude more expensive to try to fix something after the fact from an incident response perspective than if you invested in that security ahead of time, right? So very costly, and I think that correlates well to the data that I've seen in the cybersecurity world, right? And I like the little sign I've got there on the bottom that says, if you don't schedule time for maintenance, your equipment's going to schedule it for you, which I think is absolutely true, right? So we talked a little bit about these other maintenance schemes, not run to failure, right? So the predictive methods or the schedule methods or this testing of the lube oil, right? So let's take a look at what do these methods look like in cybersecurity. So think about this, physical machinery, but how do we extrapolate some of these maintenance methods and sort of planning methods? How do we extrapolate that over to cyber? Is there the equivalent of kind of preventative maintenance for cyber? And I'll talk through some of that. And again, I encourage you to ask questions as we go through the chat, and I'll do my best to try to keep up and answer them. So I look at preventative maintenance, which would be like a schedule-based maintenance. So changing your oil every 3,000 miles or 5,000 kilometers if you're a Canadian or if you're in Europe. I look at that as kind of similar to the compliance folks, right? So these are the folks that bring in an assessment team. So you come in and your compliance officer says, thou shalt do a risk assessment once a year or once every 2 years, or you shall do a pen test, every year or every 2 years. So on some sort of calendar or schedule basis, you are encouraged to bring in some experts and do that. And there's certainly a lot of consultants and a lot of organizations that will do that for you, right? So you come in and you do a sort of a point in time snapshot of what's the security look like in this organizations, right? So you take a tool in the IT world, we would take a tool like Nessus, we would scan the IT assets, we would provide you with a report that says, here are the assets and here are the known vulnerabilities in those assets. Or you could scrub, through the different log files and things. So my problem with that is that it's useful as a point in time reference, and it's certainly useful to tick the box from a compliance perspective. But I've seen way too many of those things where they basically take the report comes from the consultant, somebody flips through it, and it gets put in the safe or it gets put on the bookshelf or in a filing cabinet, and nobody ever really addresses the issues that are in that report, right? It's kind of done because somebody said we had to have a report done. Somebody said that to be compliant, we had to have a risk assessment done. But, it's really still just a point in time solution. It doesn't give you a good understanding of the long-term, continuous, improvement type of process, right? So let's look at proactive maintenance. So how do we take things from the preventative, schedule-based type of approach into more of a proactive, continuous real-time based security, right? So how do you make sure that you completely understand what's happening on your networks? How do you know what's happening with your devices, right? is the logic inside your programmable logic controller or the device that's controlling the factory? Is somebody making changes to that? Is there some sort of malware or other activity that you don't approve of that is outside of your policy that's moving around within these networks? And do you have the mechanisms in place to be able to detect those changes, right? To see what's happening. So in the maintenance world, like in the electrical maintenance world, especially, I kind of look at that like thermal imaging, right? So you've heard of a FLIR camera, forward-looking infrared. So back in the day when I ran crews of electricians, we had some cameras that these cameras costed maybe $50,000, right? So an electrician or an engineer, electrical engineer, would go get this really specialized camera, and they would take pictures of either electrical switch gear or a running motor, or they would take some pictures of these things to try to find a hotspot, try to find, is this piece of equipment running within specification? And in this case, this picture is of a pump and of a motor. And you can see on the motor, it looks red, which probably isn't a good thing from a temperature perspective. But of a special concern is the portion of the motor that's white. So that portion of the motor that's white is a part of the windings that's really, really hot. So in this particular case, I believe what they found is they found that the cooling fan on the back of the motor had broken. And so the motor wasn't being cooled properly. But you can take a picture of the motor while the motor's running. So the factory's still running. Whatever this motor and pump is pumping around is still running. You're still making product. You take this picture. Well, now you can schedule. You can say, okay, Jim, or okay, Lisa, we need to schedule some time to replace or to repair this motor the next time that area of the plant is shut down for cleaning, right? Maybe this particular plant has to shut down every week, and every week they take a cleaning run, and they can schedule the time to repair that. So that's good because you don't lose time, right? And in the OT world and in the factory and production world, I have drilled into my head that there's 1,440 minutes. There's 1,440 minutes in every single day. And the reason I know that is because if the control system was responsible for 1 minute of downtime on some machine, Marty had to stand up in front of the mill manager or the production staff and explain how that never was going to ever happen again, and what measures we put in place to prevent it from happening. And some of those measures on the electrical side were things like this: take a picture of the machinery while it's running, find out where the hotspots are, and then set it up so that you can fix it in a time that's convenient to you, and it costs you less money that way. So let's look at how we look inside these devices, right? Wouldn't it be neat to be able to see inside of your OT devices, to be able to tell if these networks are running in the right way, to tell if this device is having, the right parameters and things, or is there anything changing here? So we do that through a variety of mechanisms, and this isn't a product pitch per se, but I don't think that you can look at these environments with one singular lens. I think you have to use a whole suite of tools to be able to look at these devices and understand what's going on in front of them. The first one I would say would be you need to passively monitor these networks to see what traffic is going on, and look at the changes that are going on in the network. But we found that simply wasn't enough. You didn't get enough information out of these devices. A lot of these devices are quiet. They're designed for low bandwidth environments, and they're designed not to only speak when spoken to, request response types of communications. So passive only detection technology doesn't really cut it. So within Tenable, we developed the technology to look at these devices from an active perspective. And a lot of people in the OT and industrial control system world get completely freaked out or scared when we say the word active. And I want to make sure that you understand that this is not active scanning. We're not going out with Nessus or Nmap and spraying the network with packets and hammering these devices to try to figure out what they're doing. When we say active querying, what we mean is we are using the OEM equipment vendor's own protocols in a very safe and reliable way to ask the device, what are you? What do you do? What firmware level are you at? What logic changes have been made in the past 24 hours? Or can you provide me with a copy of your logic? What position is the key on the front of your programmable logic controller? Or is somebody allowed to make changes? Is it in program mode? Or is it in run mode where it's locked out, where no changes can be made? The vendors themselves have used this method for decades. So this is how the vendor actually makes the changes in the system itself. We're just replicating or emulating that. It's very safe, it's very reliable, and it gives us an incredible amount of device situational awareness, or an incredible amount of information about what is that device doing, how is it doing it, and can we monitor that for any deviation or any problems. So that level of active device querying gives us that visibility, like the thermal imaging, to see what's happening inside that device. And you, quite frankly, you cannot get that through passive means alone. So one of the biggest takeaways is I encourage you to look into active querying. It's safe, it's reliable, and it's well trusted in a lot of our customer environments, right? So the next part that you get here is kind of like this lube oil thing, right? Where we test the lube oil for the machine and look at all the different parameters. If you have a complex operational technology environment and industrial control system environment, I guarantee you that you have alerts and data coming in just by the truckload, right? There's syslog events, there's detection events on the network, there's new devices being added, there's signatures that are tripping. You really need to take a look at the tuning and the fine tuning of how to mine that data to get the benefit out of it. And here's where I'm going to put in a pitch. It's like, Tenable is a technology company, no questions about that. But you need to have people, you need to have process, and you need to have technology. And I'll argue that you need to have people first. You need to have the right people. They need to be the right skill set of people. And you need to have the right number of headcount, quite frankly, to manage the security in one of these operational technology systems. And way too often I see control system engineering people that are also saddled with security, right? And quite frankly, we have to get beyond that as a community and as an industry. We need to be hiring the right people to do the job. We need to have the governance and the policy and the procedure in place to tell those people and let them do their jobs in the right way. Then we need the technology to support that, right? So you need all three. You need people, process, and technology. So once you have that all in place, you can really fine tune the data you're looking for, right? And you can tell with a high degree of accuracy what's going on in these networks and how to flag, any issues or anomalies that are there. So we do that in our product, and other products are very similar, but we do that through three primary mechanisms. So we do that where we're passively ingesting the data on the network. We're running that through a policy engine. So you state what's in and out of bounds, right? So I don't want to see anything like this. Okay, it's a blacklist. I only want to see things like this. You have a whitelist of traffic. And I've been told I need to come up with better terms for whitelist and blacklist. So I apologize there. That's not a very proper way for me to explain that. Let's just say We have a list of things that are allowed, and we have a list of things that aren't allowed. And you can flag against that using policies. So a very powerful engine to help you maintain that you're in compliance with those policies and procedures. We also run that through an anomaly-based engine. So for example, we know all of the protocols and ports and things that are talking on your network. If we see a new protocol, or we see a new device, or we see a device that should be there that drops off, we can give you an alert, right? So we can do some anomaly detection on there. The last one is we do a signature-based detection. So we run the network traffic through a known signature method that we use right now. We happen to use Suricata. And so you can see known malware strains or known badness, known file hashes. If they're on your network, we'll give you an alert. So very comprehensive analysis of the passive traffic that's on there, right? And so that's kind of like the lubrication oil analysis. We're looking at the network traffic as it goes by. And if there's something that goes, oh, well, this shouldn't be here, we should take a look at that. You need to fix this because, the oil is wearing out. The network is wearing out. The network has too much traffic, or there's another kind of a protocol that shouldn't be there. Somebody needs to take action. So you're doing that kind of preventative maintenance in that way. One of the last things that I think is really unique, and I really like it because I'm a control system engineer, is because we're doing this active device querying, we're able to take and extract a copy of the configuration from the controller. So the actual programmable logic controller, has ladder logic and it's executing instructions. Well, what happens if somebody changes that in the middle of the night? Was that an approved change from an approved workstation by an electrician who perhaps was executing a work order to change this rung of ladder logic? Well, you can look into that. Or was this a disgruntled employee or malicious insider that was, making a change, like planting a logic bomb or something like that? Well, you can check into that. Or was this malware on the network? So was there a laptop that was on the network that the actual malware on it was trying to make changes to the logic, think Triton Trisis sort of situation? Was there actual changes trying to be done to the logic? Well, what you can do is you can take a snapshot of the running configuration, and then you can compare it to the previous or the gold image, right? You can compare it to the known good running configuration. And this can really help you from a troubleshooting perspective. So this has a high amount of value for the engineering and the production folks, because this helps them troubleshoot the running process, right? So this is kind of one of those features that it's a security feature, but it's not a security feature. So you can use it to troubleshoot the plant to help you get back up and running properly, or you can use it as a forensics tool from a security perspective to go, oh, there was these things happening on the network and we saw these alarms. Were there any changes in the logic or any changes in the device configuration that were done at the same time? Hugely powerful forensics tool. So in summary, I guess what I would like to say is what I've tried to do is I've tried to correlate some fairly well-known maintenance types of activities in the real sort of factory or production world to things that you should be doing on the cybersecurity space. And I maintain that, installing your operational technology or installing your millions and millions of dollars worth of control system equipment and then kind of ignoring it and running it, driving that car until it fails, and then calling the vendor to come in and fix it, or calling the incident response team to come in and try to figure it out, right? They got to reverse engineer everything and troubleshoot everything. That's not the right approach. Take a proactive approach. Look into proper asset inventories and asset management systems. Look into detection mechanisms to see what's happening inside of these devices and what's happening on your network. Get the right people in place to be able to look at these things on a daily or weekly basis so that you can take action before you get to that incident response. And I guarantee you that it will cost you much, much less over time, right? Get to that sweet spot on that curve, right? And once you get to that sweet spot, I think you'll be in a much better place. And hopefully you'll be able to prevent things like ransomware or things like commodity-based malware doing too much damage. I mean, you can't prevent everything, right? Something bad will happen eventually, but you're going to have the data to be able to troubleshoot it, get back to normal state as soon as possible. And over time, it will save you money. So I think that the most critical thing, and when I talk to chief information security officers or I talk to security teams, they come to me and they go, Marty, we have no idea what we have as far as inventory on the OT side. We know we've got all these devices. We know we've got all these micro-segmented or semi-segmented networks. But guess what? We also know they're all converged. Everything's talking to everything. So we need visibility. We need to see into those systems. We need to see into the protocols and sort of the purpose-built esoteric vendor-specific protocols and implementations. So we need help there. And I guess I maintain that the best time to do that is before an incident occurs, right? Go in, properly instrument these environments, get the data out, combine that data with the data on your enterprise side. So it's of no use to see only the data that lives in your OT system and only the data that lives in your enterprise system. The chief information security officer who has to give that report to the board of directors who have fiduciary responsibility for the company, they need to evaluate risk across all of those platforms. So pick a good partner, get the information that you need, and take action on it. Ask as many questions as you want in the chat window. I hope this was a valuable session for you. Again, my Twitter handle is ICS_Marty. Look me up and be a follower, and we'll have a great conversation. With that, good luck with the rest of your sessions, and I hope you enjoyed my session. Bye-bye for now.